we're going to show something in this video which you're not allowed to use in class. You're not allowed to use it in the assignment, but you should see what happens. So that's fairly mean of me, but nevertheless, we are going to prove a theorem, and this theorem says the following. It says that the limit as, let's go with theta, as theta goes to 0 of sine of ax over bx is equal to the limit as theta goes to 0 of ax over sine of bx is equal to the limit as theta goes to 0. I don't know why these are thetas while these ones are x's. Well, I do know it's because I am not very good at paying attention. There we are. Limit as theta goes to 0 of sine of a theta over sine of b theta, and that each and every single one of these is equal to a over b. The reason I don't want you using the theorem is because I want to see that you can figure out the process of finding limits with sines and cosines. This bit over here in particular, showing that this is equal to a over b, I want to see that you understand it. I might only be able to test whether or not you've memorized it, but that's at least an improvement. So let's say we have sine of a theta over sine of b theta, and we're trying to show that this is equal to a over b. So I'll prove this, and you can prove the rest of these on your own. So proof of that part, if I have the limit as theta goes to 0 of sine of a theta over sine of b theta, well, what I can definitely do with it is I can look at sine of a theta, and I can say that if I had a theta on the bottom, that certainly gets me very, very close, because the limit that I know, the thing that I'm allowed to play with, is the limit as box goes to 0 of sine of box over box is equal to 1. And so this gives me a theta over here, a theta over here, not yet over here, but hopefully I'll be able to cover that up in a little bit. But I can't just divide by a theta, I also have to multiply by a theta. At which point I realize, well, I'm still missing something. My sine of b theta kind of went away, which isn't terribly good, but if it had a b theta on the top, well, that would be extremely convenient. It would just be 1 over this limit, which is 1 over 1, which is also equal to 1. But if I multiply by b theta, I have to divide by b theta. And now I have one box over here where this is good. This one is also good. I can play around with both of these very nicely. And what's left has thetas canceling out. And so the first bit, if theta is going to 0, and I multiply theta by a, then a times theta is also going to go to 0. So the limit as a theta goes to 0 of sine of a theta over a theta is equal to what we have over here. Put this in brackets, times a over b, that doesn't even require a limit because it's a constant. And this here is the limit as b theta goes to 0 of b theta over sine of b theta. And so this is 1 times a over b times 1, which is equal to a over b. Again, lovely theorem. I don't want you using it in the assignments. I want to actually see the process of thinking it out every single time.